Hello and welcome to this video on energy from nuclear reactions for GCSE physics. Fission is the splitting of a large unstable nucleus into smaller, more stable nuclei. This can happen on its own, called spontaneous fission, but spontaneous fission is rare. Usually for fission to occur, the unstable nucleus must first absorb an extra neutron. This is what happens in nuclear reactors. In this example, a fissionable isotope of uranium is used, but you also need to know that plutonium is used as a nuclear fuel. When uranium-235 absorbs an extra neutron, it becomes uranium-236. This isotope is so unstable that the nucleus splits apart. From this split, several things are emitted. 2 smaller nuclei, roughly equal in size, 2, sometimes 3 neutrons, and gamma rays. The particles, the smaller nuclei and the neutrons, are moving, so they have kinetic energy in their stores. The rest of the energy given out in the fission reaction is carried away as gamma rays. All of this energy can be used to generate electricity. The neutrons given off in a fission reaction may go on to start a chain reaction. If there are more uranium-235 nuclei and the neutron is travelling slowly enough, the neutron could be absorbed by another uranium-235 nucleus. This causes another fission reaction, which gives out more energy and more neutrons. These extra neutrons could go on to fission more uranium-235, and so on. This is a chain reaction, and is needed in a nuclear power plant for generating electricity. This is a diagram of a nuclear reactor. Cold water is pumped in, and this is heated by the energy released in the fission reactions. The heated water is pumped out, and the heat in the water is used to heat a second store of water and produce steam. The steam turns a turbine, which turns a generator, and electricity is produced. The second store of water is required so that radioactive materials are contained in the reactor. Only thermal energy is exchanged between the 2 water stores. The chain reaction which generates the thermal energy needs to be carefully controlled. If it's not carefully controlled, too much energy is given out. Too much energy will cause damage to the nuclear reactor, and radioactive material could be released into the environment. To control the amount of energy, the number of fission reactions per second has to be reduced. This is achieved by using boron control rods. The control rods absorb neutrons, so less fission reactions can take place. The control rods can be lowered when the reaction is producing too much energy, and raised again when a lower energy level per second is reached. A completely uncontrolled fission reaction is what happens in a nuclear weapon. This is where vast amounts of energy from fission are released in a very small amount of time. Fusion is a different nuclear process. This is where 2 small nuclei are joined together to make a larger nucleus. This is the process that happens in stars. Here we have 2 isotopes of hydrogen, deuterium and tritium. Isotopes have the same number of protons, so they both have 1 proton, but different numbers of neutrons. Deuterium has 1 neutron. Tritium is slightly heavier with 2 neutrons. As each nucleus has a positive charge due to the positive protons, they repel each other. To get them to join, they have to be travelling towards each other at high speeds. When they're close enough, a force holds the protons and neutrons together to form a new, larger nucleus with 2 protons. This is helium. In this fusion, some of the mass from the original nuclei is converted into energy. This energy could be used to heat water, which could be used to generate electricity, and there are several groups around the world who are trying to make fusion reactors viable. In your exam, you may be asked to compare fission and fusion. For their similarities, they both produce energy. For their differences, fission splits a large nucleus into smaller nuclei, whereas fusion is the joining of 2 smaller nuclei to make a large one. Other differences include fission produces toxic nuclear waste, whereas fusion produces helium, which is an inert gas. That's all for this video. Thank you for listening.